I have an existential question before we move on. The system of equations that we just solved had a solution and a single solution, right? A single point of intersection, negative 3, comma 1. How would I have to arrange these two lines on the graph in order for there actually not to be any solution to this problem? How can I draw two lines in an xy coordinate system in a way where there is no intersection point? This calls back to something we were talking about a little earlier today. Right. If I draw these two lines in a way that they are parallel to one another, so if I just sort of turn this blue line around and make it look like this, now no matter how far I zoom out, two parallel lines are not going to have an intersection point in the xy plane. And so if I were to try to solve this system of two equations, then I might end up getting stuck. And just for clarity, the system that we would be solving in this example, all I did is I took the slope of this second line and I tweaked it so that this new line is parallel to the first line. And remember, parallel lines are lines that have equal slopes. So that means that I would be solving this system, y equals x plus 4 and y equals x minus 6. And we would expect, based on the fact that these are parallel lines, we would expect this system to have no solution at all. That's something that the graph would tell us, just based on what we know about parallel lines, but it's also something that the algebraic methods that we're about to develop for solving systems of equations are also going to have to be able to turn up one of these weird cases, where there's not actually a solution because there's not a point of intersection between the two lines.